Hello mga Ka-Acute Angels! Welcome back for another matinee episode. This is Teacher Mika
And this is Teacher Joyme. Today, we will learn about subsets of real numbers. But before we start, kindly prepare your self-learning module, your pen and paper to write your solutions and answers as we progress with our discussion.
Also, look for a place in your home where you feel comfortable and safe. And most importantly, prepare yourself to watch and listen carefully.
After going through this module, you are expected to
describe and illustrate the real number system.
Classify the number by naming set or sets to which it or they belong or belongs using Venn diagram.
Arrange the set of real numbers in increasing or decreasing order.
And plot the set of real numbers on a number line. Let's check your previous knowledge about rational and irrational numbers. Given inside the box below is set of real numbers. On a separate sheet of paper, box all the irrational numbers and encircle all the rational numbers. 5 square root of 3, 2.333 and so on, 2 and 1/2, pi, 12 over 17, negative 5.6, 3.123, and so on, and negative 40. I will give you 1 minute to finish this task. Now, let's check your answers. Irrational numbers are square root of 3 and pi. Rational numbers are 5, 2.333 and so on, 2 and 1/2, 12 over 17, negative 5.6, 3.123 and so on, and negative 40. I hope you got the same answers because your learnings about these two concepts will equip you to the lesson subsets of real numbers.
Let's start with lesson 1, illustrating the different subsets of real numbers. In this lesson, we will classify real numbers into subsets and show how this idea relates with 5 types of numbers. Using Venn diagram and number line, we will learn how to conceptualize the subsets of real numbers. Let's talk about these 5 types of numbers. We'll start with the counting numbers, also known as the natural numbers. These are the numbers that you use when you first learn how to count. Examples are 1, 2, 3, 4, and so on. Another subset is the whole numbers. This subset is exactly like the subset of counting numbers, but this time, it includes 0. The subset would look like this: 0, 1, 2, 3, 4, and so on. A third subset is the integers. This subset includes whole numbers, not fractional numbers, that can be positive, negative, or 0. The subset would look like this: negative 4, negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3, positive 4, and so on. The next subset is the rational numbers. From our previous discussion, we learned that rational numbers are numbers that can be written in the form a over b, where b is not equal to 0. This subset includes fractions. Examples are 1/2, 1/3, and -7/16. Terminating decimals like 0.5, -0.4375, and repeating decimals like 0.3333 or written as 0.3 with vinculum symbol above the number that repeats. Lastly, we have the set of irrational numbers. This subset includes numbers that cannot be expressed as a ratio of two integers. In layman's term, these numbers cannot be expressed in fractional form. It has decimal that goes on forever without any repeating pattern. Examples of irrational numbers are pi, because its decimal form has no pattern and does not end. Same with square root of 2, Euler's number, and 4.626578, and so on. To summarize, the real numbers is the set of numbers containing all the rational numbers and all the irrational numbers. Rational numbers include integers and fractions, which are also known as non-integers. Under integers are whole numbers and counting or natural numbers. Irrational numbers are numbers that cannot be expressed as a ratio of two integers. They are non-terminating and non-repeating decimals. The real numbers are all the numbers on the number line. For example, this number line shows -3.5, -7/6, 0.345555, and so on, square root of 3, and pi.
For your practice, answer the activity 1.1 of What's More on page 11. Classify the real numbers to which subset or subsets of real number belongs. Whole number, integer, rational, irrational. Use a check mark to answer the following: -3, 0, 4/7, square root of 64, 13, -0.125, square root of 2, Euler's number, and 0.50. I will give you 3 minutes to answer this. Let's check your answers. For negative 3, is it a whole number? No, because whole number only includes positive numbers and 0. Is it an integer? Yes, because integer includes negative numbers, 0, and positive numbers. Is it irrational? Yes, because integer is a subset of rational numbers. For 0, is it a whole number? Yes, because whole number includes 0. Is it an integer? Yes, because whole number is a subset of integers. Is it rational? Yes, because integer is a subset of rational numbers. 4 over 7. Obviously, it is not a whole number. Is it an integer? No, because integer are whole numbers which are negative, 0, and positive. Is it rational? Yes, because it is written in the form a over b where b is not equal to 0. Square root of 64. The principal root of square root of 64 is 8, which is a whole number. If it is a whole number, it is an integer. And if it is an integer, therefore, it is also rational. 13. 13 is a counting number, which is a subset of whole number. If it is a whole number, it is an integer. And if it is an integer, therefore, it is also rational. Negative 0.125. Is it a whole number? No, because whole number only includes positive numbers and 0. Is it an integer? No, because integer are whole numbers that can be positive, negative, and 0. Is it rational? Yes, because the given is a terminating decimal. For square root of 2 and Euler's number, they are irrational because they cannot be expressed in fraction form. And lastly, 0.50 is not a whole number and not an integer, but it is a rational number because it is a terminating decimal.
Congratulations! You just finished the first part of this module. You can now answer Activity 1.2, What's More on page 11, What I Have Learned on page 12, and What I Can Do on page 13. Let's have Lesson 2, which contains exciting activities in arranging real numbers in increasing or decreasing order and on a number line.
But before we proceed, let's have a brief review. Write capital letter T in the blank if the statement is true, and write capital letter F if the statement is false. For number 1, all rational numbers are real numbers. Number 2, an irrational number is always a real number. Number 3, every whole number is an integer. Number 4, every decimal number is a rational number. Number 5, all real numbers are integers. Number 6, 15 is an irrational number. Number 7, 0 is an integer. Number 8, all natural numbers are sometimes positive. Number 9, all repeating decimals are irrational numbers. And number 10, there are no natural numbers between negative 5 and 0. I will give you 3 minutes to write your answers on a clean sheet of paper. Let's check your answers. Number 1. All rational numbers are real numbers. True, because rational numbers are subsets of real numbers. Number 2. An irrational number is always a real number. True, because irrational numbers are also subset of real numbers. Number 3. Every whole number is an integer. True, because whole numbers are subsets of integer. Number 4. Every decimal number is a rational number. False, because there are non-terminating and non-repeating decimals which are irrational numbers. Number 5. All real numbers are integers. False, because real numbers include rational and irrational numbers. Number 6. 15 is an irrational number. False, because 15 is a counting number which is a subset of rational numbers. Number 7. 0 is an integer. True, because integer includes positive numbers, negative numbers, and 0. Number 8. All natural numbers are sometimes positive. False, because all natural numbers are always positive. Number 9. All repeating decimals are irrational numbers. False, because all repeating decimals are rational numbers. Number 10. There are no natural numbers between -5 and 0. True, because natural numbers start with 1, 2, 3, 4, and all the counting numbers.
Now, it's time to explore the adventure of Ben, Chad, and Kent. Ben traveled 4 kilometers from their school to the left, 0 being the place of origin, and Chad did the same but traveled 2 kilometers longer than Ben. On the other hand, Kent traveled to the right, starting from the same origin with the distance of 3 kilometers. Let's locate their position. Ben is at -4. Chad is at -6. And Kent is at +3. Now, are you ready to learn the steps in arranging real numbers? Step 1. Change each number to decimal. Step 2. Write the decimals in order from least to greatest or greatest to least. Step 3. Write the decimals to their original form with their new order. Example number 1. Arrange 2.55 and so on, square root of 9, 15 over 4, and -11 over 5 in ascending order and plot the numbers on a number line. So let's have our solution. Step 1. Change the following numbers to decimals. 2.55 and so on is approximately equal to 2.56 when rounded off to the nearest hundredths. Square root of 9 is equal to 3 because the square root of 9 is 3. 15 over 4 is equal to 3.75 because 15 divided 4 is equal to 3.75. -11 over 5 is equal to -2.2 because -11 divided 5 is equal to -2.2. Step number 2. Arrange 2.56, 3, 3.75, and -2.2 from least to greatest. So we have -2.2, 2.56, 3, and 3.75. Step number 3. Change the decimal form to their original form. The original form of -2.2 is -11 over 5. The original form of 2.56 is 2.55, and so on. The original form of 3 is square root of 9. And lastly, the original form of 3.75 is 15 over 4. So therefore, the order from least to greatest is negative 11 over 5, 2.55 and so on, square root of 9, and 15 over 4. We are now ready to plot the points on the number line. Negative 11 over 5 is negative 2.2, which will be plotted between negative 2 and negative 3, but much closer to negative 2. Next is 2.55 and so on, which is approximately equal to 2.56, and will be plotted approximately at the middle of positive 2 and positive 3. Third, the square root of 9 is at positive 3. And lastly, 15 over 4, which is 3.75, will be plotted between positive 3 and positive 4, but closer to positive 4. Example number 2. Which of the following is the largest? Square root of 4, negative 5 halves, 3/4, negative 0.30. Here is the solution. Step number 1. Change the following numbers to decimal form. Square root of 4 is equal to 2, because 2 square is equal to 4. Negative 5 halves is equal to negative 2.5, because negative 5 divide 2 is equal to negative 2.5. 3/4 is equal to 0.75, because 3 divide 4 is equal to 0.75. And lastly, negative 0.30 will be copied since it is already in decimal form. Step number 2. Arrange 2, negative 2.5, 0.75, and negative 0.30 from greatest to least. Therefore, we have 2, 0.75, negative 0.30, and negative 2.5. Step number 3. Change the decimal form to their original form. The original form of 2 is square root of 4. The original form of 0.75 is 3/4. The original form of negative 0.30 is still negative 0.30. And lastly, the original form of negative 2.5 is negative 5 halves. Therefore, square root of 4 has the largest value. You did great in watching and listening. Now, you can confidently answer the following activities on your module. These are what's more on page 17, what I have learned, and what I can do on page 18.
That ends our lesson today.
We hope you learned something. See you on our next episode, Ka-Acute Angels. Keep safe!